Good day. Welcome to the Simulation and Testing Virtual Congress, and I hope you enjoy my presentation. My name is Wicher Kist. I'm the CEO of Saietta Group in the UK, and we are a electric drive solutions specialist. We are an engineering service provider. We offer superior axial flux motor technology and turnkey engineering services with the mission and vision to accelerate the introduction of electric propulsion into all areas of transport, from niche volume to mass market. We're based in Oxfordshire on an airfield, the ex-Squadron Command, fantastic proving ground. But we also have a small assembly plant in Gandhidham in India. My background, I'm an automotive engineer, 23 years of experience, and specialized in powertrain areas, starting with combustion engines with COSWORTH. Worked very closely with Bentley, Ford, Rolls-Royce, VW, all kinds of supercars. But during the last 10 years, I've also been very actively involved in green technology, like fuel cells, batteries, solar, wind, and with Saietta powertrain solutions. So, India, COVID. My personal passion, how can we clean up the air in large cities around the world? That is something that I think about a lot, and therefore I'm honored to be invited as a speaker today. Here a fantastic picture of what it was like and what it is during COVID, and it does play on your mind. Is this a preview into the future? Now, what could the future look like? This vehicle we already know. I've been in it many times, traveling all around India under normal circumstances and promoting our technology. But what I find interesting is if you take certain limiting factors out of it. So let's imagine no driver. And if you don't have a driver, you don't need a steering wheel. And obviously, we're switching to electric, and that might take some time, but we have to start thinking about it. No engine and no gearbox. Now, that is interesting. And as a product designer, let's add a few more design wishes. Let's say we want it to be modular and a flat floor for simple battery construction. And if the floor is flat, then there is no space for the powertrain. Otherwise, the floor has to go over the powertrain. So, but there is a fantastic space in the wheel. And if we can move that drive technology into the wheel, then that's where it belongs. Now, let's apply that in a very simple way. The wheels are the same, but a flat platform. And instead of going for this shape, stipulated by the driver position and the combustion engine, it could also be this shape. And that might sound far-fetched, but I don't think it is. I'm a good observer. People say I'm a good inventor, but I'm actually a really good observer, and I spend a lot of time scanning the world of what new technologies are good and why do they work. I found one particular one, and it's this one. It's not mine. I didn't design it. It's Toyota e-Pallet. And as you can see, it's a pod with a flat floor where people can stand up and there is no driver. And this is not for tomorrow, but we have to start thinking about this. I was in Bangalore a couple of months ago, and I was fascinated with the beauty. It's so beautiful. But let's imagine Bangalore without horns and without smoke and without noise and just little vehicles like this buzzing around. Now hold that picture and look at this video.
Multifunctionality. Designed to help a range of companies utilize advanced mobility technology to better serve customers 24/7 on demand. logistics innovation, automated delivery services from distribution center to final destination, using right-sized and right-placed mobile solutions. Our vision of future mobility services and mobility commerce.
It's on YouTube. You can find it yourself. It's a few years old. It's, I think, 2 or 3 years old, and Toyota is actively working on it. Autonomous driving will come. Driving vehicles ourselves will become a thing of the past. I'm a car guy. I don't want to stop driving, but if I could have a pod taking me to a racing track and go racing, electric obviously, that would be fun. But driving on the public road, why would we do it ourselves? So just to trigger some thought, one thing's for certain: affordable and reliable in-wheel motor technology is required, and that's a mission I started with my team a couple of years ago, and we are working on it hard. We are developing different versions for different clients, but it's not so much about what we do. There are a lot of companies doing this, and the wheel is the perfect place to adopt the drive tech. With a combustion engine, that was not possible. With electric drive, it is. Or do nothing. The alternative is to change nothing and go back to how it used to be. I sincerely hope that COVID is a time of reflection where we can look ahead in time and imagine how it could be. The alternative is change, and change is good. Now, back to today, back to India. I've traveled around India for a number of years, and I find it a fascinating country. Compared to China, for example, where you have plenty of little electric mopeds, there's something unique about India, and that is how much Indians put on their motorbike. Motorbike is a fantastic solution, but you need enough power to keep doing this. I'm not saying it's entirely safe, but if this is what the people want to do, we need to create solutions to satisfy the customers. Now, 20 million motorcycles are sold every year. It's enormous. If I tell my relationships in Europe, they're just like, and the distribution is roughly like this. The focus or the bell curve sits pretty much at 110 cc's. The predictions are it's going to go up, but that's where it sits today. And it is the perfect commuter solution. It's light, it doesn't take much space, it's easy to maneuver, and it's affordable. And I've learned that about India. It is very cost sensitive. But it's always petrol. CNG is not possible, diesel not entirely the right idea, and the majority is 110 cc's. Now, being more of a product architect, I just see the opportunities, but I also realize that smaller than what people use today is not going to work for India. The road conditions are not right, etc. But going too big is going to be too expensive. So there is an interesting market segment, and that market segment can go electric now. I know everybody is thinking about 4 kilowatt motors, but I think we should go a little bit more powerful and get this right. And I'm going to try and explain that. But first, the biggest concern. There are two, essentially, in my opinion. How to charge at home. You live in that flat and you park there on the street. Are you going to throw an extension lead out of your balcony? I don't think that's legal, and I don't think that's wise. And batteries are expensive, and they will probably be expensive for the next 5 years, maybe 10 years. So this needs a bit more clever thinking. The solution could be don't buy the battery and don't charge at home or at work. So that triggers the thought of, or the question really, can swappable batteries work for a 10 kilowatt motorcycle? Because 110 cc's is about 10 kilowatt. And in my humble opinion, the answer is yes. And a lot of that is design and simulation and working together, combining European technologies with Indian technologies and making it local. Now, as I said, I'm a good observer. I look at a global level, not at a continent or a country level. And there's one particular example. It's a Taiwanese success story. And I'm going to show you again a small video of about a minute. The company is called Gogoro, and together with Panasonic, they developed a 1.3 kilowatt hour battery. It's the size of a milk cartridge. It's about 10 kilograms. And as you can see, young people can carry it. And they have made this available through a subscription. And I believe there's a lot of centers already. I've got some statistics later. With these type of docking stations, if you ride along and the reserve light goes on, ping, you can just stop, flash your card, 2 batteries pop out, you swap them, you don't own them, you don't have to be nervous, and basically in 6 seconds you're done. Now, imagine that this battery would be suitable for a 110cc motorbike. I'm already building a few in the UK. I'm going to prove to the world that this is possible. How does it work? Innovative battery swap subscription service, so you don't have to buy it. And it's available 24/7. We can even add it to existing petrol stations as their fuel requirement reduces. And like I said, if someone's going to fix this battery bottleneck in the launch of electric drive worldwide, it's going to be the companies like Panasonic. And Panasonic is behind this one. Get it into India, make it locally, roll it out with government support. That's the way forward. The network is growing extremely fast. This particular company started in 2015. Since early 2020, they already had 1,600 swapping stations and about just over 250,000 users. They have completed over 70 million battery swaps. It works. This is the concept to adopt globally. Even from Europe, there is interest because we are considering A1 motorbike license for vehicle drivers to take people out of public transport. So the 125cc motorbike, or the petrol equivalent, the market is going to be booming over the next 10 years. Now, going back to Gogoro, I read blogs and the forums, and I found this one particularly interesting. Not my text, taken directly from the internet. As a owner of a Gogoro and living in the crowded city of Taipei, I am more than happy with the swapping system. The maximum time I have waited to change a battery was 1 minute because of 2 people in front of me. Also, by renting the battery, I don't have to worry about the battery degradation. A few months ago, they introduced new batteries with more range. We can always have the latest battery tech and no need to buy a new scooter. I'll go a step further than that. The battery technology is nothing exciting. They are the cylindrical cells, and you can effectively, after, say, 2 years of use or 5 years of use, whatever the life cycle is of that battery pack, you can then dismantle them, take the batteries back, recycle them, and upgrade it to the latest technology. I think this is the way forward. Now, to conclude this quick introduction, it seems that we've arrived at the tipping point to go electric for lightweight mobility at a global level. The technology is ready. Create an electric motorcycle with enough power to make clients happy. Let's not forget that. Vespa have tried it with a 2 kilowatt scooter. The reviews are not very good. Let's put a bit more power in there. My electric car is very powerful and it's very enjoyable, and I don't drive any of my other cars anymore because it's fun to drive. 2, sell the motorcycle for less money than the petrol alternative. And it can be done. That can be done. As long as the battery is not included, we can seriously compete with a petrol equivalent. And then 3, create a battery subscription model that costs less than the fuel consumption today. That opens a market that is enormous. A few recommendations. Let's implement this together during the next 5 to 10 years. This is going to take the captains of industry and the government to work together. We must act now to switch a substantial portion of the L3E A1 motorcycle category to electric. For India, likely to be 60 million units within the next few years. Global predictions say that we're heading towards 150 million units. It's a great opportunity to do good and to make money. During this period, we can develop the drive technology into the wheels and start rolling out autonomous pods at a global level. It's happening. I mean, I can see it here in Amsterdam, in London, in Berlin, in Paris, but also in the Middle East, also in China. Pods are coming. We need to bring that drive tech into the wheels. Just like the switch from horse to petrol and diesel, this disruptive change will happen. Let's accept it and implement it. We owe it to create clean air for our children and the next generations to come. And this is why we develop what we develop. Simulation testing. It's all about reducing time to market. It's not really because we're in COVID. This has been done for years. I'll show you a few quick examples. The new product development process. There are many different versions, but I'll just give you a very simple one just to make it tangible. Define the product. That's where it starts. In this case, an electric motorcycle, for example. Specify the main targets. Set the price targets. What should it cost? What should the performance be? What is the target? Who is the target customer? And what are they willing to pay? And then define the main systems. I often get very involved in this phase. Battery chemistry. There are cheap batteries, but they don't do what you want them to do. They look great on paper. You build a prototype and it doesn't do what you want it to do. So battery chemistry is a big one. Driveline topology and many more questions to answer. Then you can start simulating and tuning the product. I'll show a few examples. Power, torque, battery capacity. You want to know how this marriage of technologies is going to work. And then you can start designing the system. Marry the design requirements with the mechanical parts. Now this is essentially the virtual phase and has been done for years. There's good proven processes in place to do this. But then the more expensive phase starts. So you need to start making prototypes and early samples and check if you can still meet your manufacturing targets. Then you start testing. Can the parts meet the targets in terms of cost, durability, performance, warranty, etc.? And then the validation and certifying. What we are developing here, can it actually be certified and made road legal before we can start selling it to the public? In parallel, of course, you're getting the factory ready, and then it's time to make, sell, and recover the development cost. And that's essentially the hardware phase. If you take the wrong decisions in the virtual phase, they can cost you dearly in the hardware phase. Small example in terms of simulation, we do this a lot, and I didn't want to keep this out. So what we do here is we run a fully simulated vehicle through a drive cycle. It's right behind my picture there, but here's a drive cycle. Here's the efficiencies curve in drive and in regen. And then here you can see the cumulative energy consumption over that particular drive cycle. Now, this is a great tool, but it takes a bit of homework to create this model to then get reliable figures out of it. What it really helps people like us to do is to simulate performance, but also battery capacity, so that from a very early stage, you know how many batteries you need, you know what type of packaging space you need to reserve, and then you can start designing it properly. Now, going beyond that, what do you need to create this wonderful tool and with proven correlation? I'll start at the back end. So on the output side, had demand on battery supply, current versus time, wheel and motor shaft torque, that's what we want to know. Cumulative motor controller and transmission losses, energy consumption from the battery, very key because the battery is expensive. peak and continuous gradability. If you're going up a hill, can you still get there, or does it slow down and get dangerous? And then, of course, the maximum performance to make sure that you fit in that right category. Now, to determine these, we need a vehicle model. And for such a vehicle model, we need the efficiency map of the motor. So we need to define the power and packaging space, but also the vehicle mass, the drag coefficients, the rolling diameter of the wheel. You need to decide what wheels to fit. And then what particular drive cycle do you want to look at? Or do you want to do a custom one in your region or in your part of the world? And transmission gearing and regen strategy. Again, we can lock wheels like that, but if you are on gravel roads, you don't want to do that. So as soon as you back off, it will break the rear wheel, and you will fall off the bike, and it gets dangerous. So all of these things very important. So that model doesn't come falling out of the sky. Going another step further back, we see that with all the vehicle requirements, we have to do very quick iterations of is this what the customer wants, or a slight variant, and the rapid iterations is what the market needs, and we adopted towards that. Motor loss components, we look at the copper, the magnets, the core, the windage, but also the bearing drag. It's all very critical with electric motor design, and all of this can be done in virtual reality. The controller, have you got the right controller? Because there's no point having a really efficient motor, but then you lose it on the controller side. It's the marriage. The vehicle marriage. Motor characteristics and performance, and of course warranty predictions and bearing life. I mean, we're heading towards fit and forget. We don't need to think about spark plugs and replacing oil anymore. These are fit and forget solutions we are working towards. In terms of simulation topics, things that one can consider is the electromagnetics, structural, thermal, and CFD. All of these skills we've applied for many years in combustion engines, and with the right companies, you can actually translate that to electric motor design. The electric motor is not new, don't forget. Now, I'll give you an example. This is a bike we developed a while ago with a full battery box in the middle, and we produced a number of samples, but the market demand was actually more on our motor, so we focused on powertrain. But it's a fantastic bike. We've got a couple in the shop on our airfield. It's good fun. For race applications, we've done the same with drag simulation. So again, as an example in virtual reality, here's a good example. In terms of testing, static testing, performance testing, durability testing, all of this can be done in controlled environments. And even with rolling roads, we can do vehicle testing without going on a public road. So simulation and testing, well proven and available for this technology, for this industry. So to conclude this, simulation testing of electric vehicles has been done for years. It is possible to predict real energy consumption. I don't really look at emissions anymore. I have done for many years, but it's all about energy consumption for electric vehicles, and it can be simulated. The electric motor is not new, but choosing the right topology and optimizing the motor for the application is essential. Simulation with proven correlation, may I add, can help reduce cost and time. We spend years building those correlation models. Without correlation, you think you have the answer, you then build it, and you're like, oops, it didn't work. And remote working works well. Before, during, and after this COVID pandemic, as this wonderful summit actually demonstrates today. I thank you for your time. This is my team, and maybe we'll speak in the future. If you have any questions after the summit, feel free to contact me. There's only one Mr. Kist at Saietta, and you'll be able to find me. Thank you.